Hi everyone, my name is Shankar and in this video I'm going to talk about the modulus function. Well, modulus function is denoted by y is equal to mod of x. Y is equal to mod of x. Y is equal to mod of x. This is modulus function. This is how we denote. So generally, when we talk about the meaning of modulus function, what does it mean? So let's say if I write here y is equal to mod of x and I wanted to find out the value of mod of x at x is equal to 2, x is equal to 2. It's the mod of 2 is equal to just 2. Or if I have to find out the value of mod of minus 2, mod of minus 2 is also equal to 2. So modulus function always talks about magnitude. So we forget about positive or negative sign. So whether it is y is equal to mod of x, it's always positive. This is always positive. Even if I say y is equal to mod of minus x, this is also equal to y is equal to mod of x, mod of x. So anything inside the modulus function, when you simplify, you always get a positive value. Well, modulus function mod of x is always larger than or equal to 0. For example, let's say if you take x is equal to 0, you get the value of mod of 0 is equal to 0. Let's say if I say you take x is equal to 2, so mod of 2 is equal to 2. Let's say if I say find out the value of mod of x at x is equal to minus 2, you get mod of minus 2, which is 2. Well, we can look at some other modulus function also. Let's say if it is y is equal to mod of 1 minus 2x, mod of 1 minus 2x. Now, if I say find out the value of mod of 1 minus 2x at x is equal to, let's say 3. So it's gonna be 1 minus 2 times 3, which you simplify, you get basically mod of 1 minus 2 times 3 is 6. So this is mod of minus 5. Mod of minus 5, you'll write it as 5. Talking about the graph of y is equal to mod of x, basically this function y is equal to mod of x is the combination of two functions. One is y is equal to just x for x larger than or equal to 0, and this is y is equal to minus x when x is less than 0. Let's look at the graph of this. So to plot the graph of modulus function, what we can do, we can make a table here. Let's randomly take some values of x. Let's say minus 2, minus 1, 0, 1 and 2. So when you find out the value of mod of x, mod of minus 2, so mod of minus 2 is equal to just 2. So mod of minus 2 is 2, so this is 2. Mod of minus 1, mod of minus 1 is 1. So for x is equal to minus 1, it's going to be 1. Mod of 0 is 0. Mod of 1 is 1. Mod of 2 is 2. Now let's plot the graph here. Let's say we have x-axis, y-axis, and we mark here the numbers 1, 2, 3, 4. We mark here the number negative 1, negative 2, negative 3, negative 4, and similarly on y-axis also 1, 2, 3, 4. So corresponding to x is equal to 0, y value is 0. So we'll mark here first point, this one, this is 0, 0. And next to the 1 we have 1, next to the 2 we have 2, next to the 3 we have 3. So you draw the graph here for positive values including the 0. Similarly, take x as minus 1, you get the value as 1. So mark this point 1. Take x as minus 2, so you get the value 2. So this point is going to be here. And when you draw its graph, it's going to be in this way. Roughly talking about the graph of mod of x is in this way. Now this is the lowest point, this one here. This is lowest point. So you can see in this graph, the lowest value of mod of x is 0. And this entire graph is above to x-axis. So we can say mod of x is always larger than or equal to 0. we can call, we can say that the domain of mod of x is basically x belongs to R, because this graph is defined, this graph is possible for any value of x. And when we talk about the range of this graph, for this graph you can see that all the values of y, all the values of mod of x are above to the 0. Okay, so range of this one is mod of x larger than or equal to 0. Looking at the graph, we can say that this graph is v-shaped graph, v-shaped graph. So any linear modulus function is always v-shaped graph. Any linear modulus function, whether it is let's say mod of 2x plus 1, mod of x plus 2, mod of x minus 3, mod of 3 minus x, all these modulus functions will have the v-shaped graph. Now one thing more about the modulus function, let's say if I ask you, you plot the graph of mod of x, and then I say you plot the graph of mod of minus x, both the graphs are same. Why? Because this value, when we simplify it, it's always positive, it is always positive, so there is no change in the graph. So similarly, we can say one thing more about the modulus function, mod of 1 minus 3x. Let's say if I talk about this is same as mod of minus of 1 minus 3x, 1 minus 3x. So you can write this is same as 3x minus 1. Okay, so in modulus function, mod of a minus b is equal to same as mod of b minus a. Now what is one thing common in these two? So if you do the whole square both the sides, so you get a minus b whole square, and this side you get b minus a whole square. Now if you simplify, this is a square plus b square minus 2ab, and then you simplify this one also, this is also b square plus a square minus 2ab. Both the things gives us same expression. So if we are given mod of a is equal to mod of minus a, right, we can say that these two things are equal. So mod of 2x minus 1 would be same as mod of 1 minus 2x. Both the things are equal here. Okay, so we can see the graph of modulus function is always a v-shaped graph, and in this case y is equal to mod of x, the lowest point is 0. Similarly, if I talk about the graph of, let's say we have some other function, let's say if you have to plot the graph of y is equal to mod of x minus 2. So how mod of x minus 2 is related to y is equal to mod of x? Well, you can plot the graph of y is equal to mod of x, y is equal to mod of x minus 2 using the transformation. So see what is the change from y is equal to mod of x to y is equal to mod of x minus 2. Well, to plot the graph of this, basically we require lowest point. We require the lowest point. How can we find out the lowest point? So equate this part to the 0. To plot the graph of modulus function, one thing more you can understand that if you get the coordinates of x-intercept or y-intercept, that will also help you to plot the graph. Let's say to get the coordinate of x-intercept, make y as 0. So in this graph, if we make y as 0, so we get mod of x minus 2 equals to 0. So we get x minus 2 equals to 0. So we get x is equal to 2. So we can mark here the point 2 comma 0, because at this x is equal to 2, y value is 0. Similarly, let's say if we plug in x as 0 there, so when we plug in x as 0, we get y is equal to mod of 0 minus 2, and you have seen that modulus of any negative number is always positive, so that is mod of 2, which is 2. So another point is 0, 2. Now if you have these 2 points, you can easily plot the graph. So what you can do, you can plot half of the graph in this way and then this way. Okay, though you don't have any coordinate in this side, but you can roughly plot in this way. So this is the graph of y is equal to mod of x minus 2. So see how the graph of y is equal to mod of x minus 2 is related to the graph of y is equal to mod of x. Simply you shift this graph y is equal to mod of x graph 2 units on the right side. Okay, so y is equal to mod of x minus 2 is going to the point 2 0 and 0 2. At the same time, let's say if you have to plot the graph of y is equal to mod of x minus 3. So to plot this graph, simply you translate this y is equal to mod of x graph 3 units on the right side. So the graph would go kind of in this way. So this point would be now 3 0. Okay, so this is how, and this point 0 3. So this is how we plot the graph of mod of x minus 2 or mod of x minus 3. Let's look at few more graphs of modulus function. Let's say if you have to plot the graph of y is equal to minus mod of x. So the graph of y is equal to mod of x is this one. This is y is equal to mod of x. Now simply reflect this about the x-axis. So when you reflect it about the x-axis, you basically get the graph in this way. So this is the graph of y is equal to minus mod of x. Minus mod of x. Let's say if I ask you, you plot the graph of y is equal to minus mod of x plus 2. So how can we do this? So basically, you shift this graph 2 units up. So when you shift it 2 units up, so that graph goes through the point 0 2 0 2. Now you can draw the graph in this way. So this is the graph of y is equal to minus mod of x plus 2. Let's say if you have to do the graph of y is equal to minus mod of x minus 2. Now to plot the graph of this, you simply draw y is equal to minus mod of x graph and then translate it 2 units on the right. So y is equal to mod of x graph minus mod of x graph is this. Now when you translate it 2 units on the right, because we have here x minus 2, so this x minus 2, when you make it at 0, you get x is equal to 2. So implies that you have to shift the graph 2 units on the right side. So graph goes in this way. So you can, this graph is basically, this goes from point 2 0, and this is y is equal to minus mod of x minus 2. So we have seen all the graphs of modulus function, which are v-shaped depending upon whether it is open to up or open to down. If it is negative modulus x, then it is open to down, and if it is positive modulus x, it's open to up. Well, other than the modulus function, we can also look at the solving modulus equations. Solution of modulus equations. Let's look at some questions. Solution of modulus equations. Solution of modulus equations. Let's say if you get a simple equation here, mod of x minus 2 is equal to 5. Let's say if you have an equation like this. Now you know that this is mod of x minus 2. This quantity could be either positive or negative, right? So we can take once x minus 2 as positive, so x minus 2 is equal to 5, and then another time you can write mod of x minus 2 is equal to 5. Now we can solve these two equations and we can get the value of x. So when we solve it, we get basically x is equal to 5 plus 2, which is 7. So one of the answers is x is equal to 7. Let's try solving this. So this is negative x plus 2 is equal to 5. We get negative x is equal to 5 minus 2, which is 3. And we get x is equal to minus 3. So we have two solutions for this modulus equation. One is x is equal to minus 3 and another one is x is equal to 7. Let's check whether these solutions are correct or not. So what we can do to check this, we can replace x by 7 in this one and check what do we get. So if we replace x by 7, we get 7 minus 2, which is mod of 5, and that gives us 5. So it implies that x is equal to 7 is correct answer. Let's plug in minus 3 also there. So when we plug in x is equal to minus 3, we get mod of minus 3 minus 2, which we simplify, we get mod of minus 5, which is 5. So you can see that this value of x also satisfies the equation, hence this is also the correct solution. So when you have to solve modulus equation, you simply remember, if it is linear modulus equation here, then what you can do, you can take this quantity as positive and also it is negative, and then make two equations, you solve them, and you get the couple of values of x. Now the question comes, why do we have the two solutions for this? Let us look at graphically. So if I plot here the graph of y is equal to mod of x minus 2, so mod of x minus 2 graph goes from 2 0, this point is 2 0, and also it goes from the point 0 2, and now on this, if you draw here a line which is y is equal to 5, draw here a line y is equal to 5. So now you can see that this line intersected these 2 points. Now these 2 points are basically the solution of this equation. That's why this modulus equation has two solutions, and one of the solution is x is equal to 7 and another one is x is equal to minus 3. Next one we can look at modulus inequation. So right here, modulus inequation, solution of modulus inequation. Well, in solution of modulus inequation, let's first write a simple inequation. Solution of modulus inequation. Let's say if we have modulus inequation here, mod of x less than 2. Now what are the values of x for which this modulus of those values is basically less than 2? To understand this, let us first plot here a number line, and let's try to understand out of it. So let's say we have here 0, 1, 2, 3, 4, and this side we have negative number, negative 1, negative 2, negative 3. Okay, now what are the numbers for which its magnitude, whether it is positive or negative, is less than 2? So you can look at this, you can find those numbers. So numbers are except any number between 2 and minus 2. So these are the solutions, any number between minus 2 and 2 excluding, right? So so the solution of this one would be then x less than 2 and larger than minus 2. Okay, simply you can write, so if it is mod of x, let's say less than 4, you can write x less than 4 and larger than minus 4. In case now if the equation is slightly different, and if it is, I'm talking about equation especially in this form, mod of x minus a is less than b, what do we do in this case? So simply you can write in same way, x minus a is less than b and larger than minus b. Now to get the value of x here out of this, so what you can do the plus a here also, and plus here also, and plus a here also. So when you do this, a and negative a gets cancelled out, so you get just x is less than a plus b, and from this side it's a minus b. That's the solution. Let's solve one question based on this. Let's say if we have mod of x minus 3 less than 5. Let's say if we have to solve this inequation, so what we can do, we can write x minus 3 is less than 5 and larger than minus 5. Well, to get the value of x, we can add 3 in all the terms. So when you add 3 here, so you get minus 2, which is less than, we get only x here because we are adding 3 to get only x, so adding 3, so here x, and this is 8. Okay, so you can see that the answer is x is between minus 2 and 8. So this is a simple modulus linear inequation where we have modulus function on one side and another side is a number. This is how we solve the modulus linear inequation. Okay, let's look at some more questions where we have x on both the sides. Okay, so let's say question says solve, in these cases you will always get linear inequation. Okay, so let's say if it says solve mod of x minus 2 larger than 3 times mod of 2x plus 1. Now we have seen one thing. If mod of a is larger than mod of b, we can also write a square is larger than b square. So what we can do here, we can do the square both the sides, so we get x minus 2 square. We can remove the modulus, so x minus 2 square is more than 3 square is here 9 and 2x plus 1 whole square. Let's expand it. So x minus 2 square is x square minus 4x plus 4 is more than 9 times. We can do this square here also. So this is 4x square plus 4x plus 1. We can simplify it further. We get x square minus 4x plus 4 is more than 9 4s are 36 x square. We can dispute this 9 inside the bracket plus 36x plus 9. We can collect all the terms on one side, so 0 is more than 36x square minus x square is 5x square, 5x square plus 40x and plus 5. We can rewrite this equation in different way, that is 5x square plus 40x and plus 5 is less than 0. Since this entire equation is divisible by 5, so we can divide it by 5 and we get here x square plus 8x. Well, this is 36x squared, so this quantity would be 35. Okay, this is 35. So when you divide this entire equation by 5, you get here 7x square plus 8x. 7x square plus 8x plus 1 is less than 0. Well, we can factorize this, so you can put here 7x in one bracket plus 1 and x plus 1 another bracket is less than 0. Now to get the answers out of this, we take the help of because this is quadratic function, this is quadratic function. So what we can do, we can plot this quadratic function. So when we plot it, we basically require x-intercept, so we can get the critical values out of this. So we can write x plus 1 is equal to 0, so x is equal to minus 1, and then we can write 7x plus 1 is equal to 0, and we get here out of this x is equal to minus 1 over 7. So these are the critical values. Now using these critical values, we can plot the graph here. So how can we plot the graph? So one of the critical values is -1, another one is -1 over 7. So kind of the graph goes in this way. Well, this point we can write, this is -1 over 7. We can mark here -1 over 7, and this another value, this another point, we can mark it as -1. So this product is less than 0 implies that we'll consider only this portion of the graph, this portion. So what is x here in this portion of the graph? So we can see x is here less than -1 over 7, but it is larger than -1. Okay, so that's the solution. That's the solution of this linear inequation, modulus linear inequation. So to solve the modulus linear equation, what you can do the whole square, both the sides, simplify, you get quadratic, factorize, and get the critical values. These are the critical values. Then plot the quadratic function curve, and then you get the solution. Okay, all right, so that's all in this video. I'll be coming up with some other videos of this chapter in the next